All right, let's get started. Welcome to this webinar on curve fitting in Origin. My name is Ishwar Iyer. I'm product manager at Origin Lab. I'm joined by two of my colleagues, Jen and Yiming. They will be monitoring the chat and the QA windows as well during the webinar. If you have any specific technical questions, please post them preferably in the Q&A window. And if you have general comments, suggestions for future improvements to Origin, etc., you could put them in the chat window. During the webinar, I'll try to monitor both of those windows and try to answer questions as they come up as well. The webinar is being recorded. Thank you, Jen, for reminding me. And you will be able to download the project that I am using, and you will be able to view or download the recording as well. Okay. Let me quickly show you where that will be on our website, so you will later be able to go there. So our web address is originlab.com. And if you click on the support menu item at the top, you will see a training webinars icon down here. And if you click that, it takes you to our webinars page. Here we list upcoming webinars. So the next one coming up after this is about peak analysis on October 15th, 2 weeks from now. And below you'll see all recorded webinars. So if you click here, you will see recordings and links to project files from all of the past webinars from many, many months. Okay. So this is a good resource for you to learn other areas of Origin as well. Plus, there are quite a few curve fitting webinars here as well. For example, one specifically on creating user-defined fitting functions, which goes much more into depth of creating fitting functions. Today's webinar is more of an overview, a broader look at curve fitting. Okay. All right. Any questions, comments? Please don't hesitate to ask. All right, let's get started. So as an introduction to curve fitting, let's first go back to the website and look at this product page. Okay, I wanted to show you this page so you get an overview of what's possible in Origin when it comes to curve fitting. So this link address will of course be in the project that we are sending to you, or rather you can download early next week, or you can navigate here from the products menu, products, Origin, curve fitting. So this page is a good resource for you to understand the overall picture that we have linear polynomial multiple regression, nonlinear curve fitting, surface fitting, model comparison, many time saving options, etc. So this is a rather detailed page, and many of these subsections have embedded videos as well that you may want to view. And at the very end, we also talk about apps. You may already be familiar with apps. I'll show some of them in today's webinar. Apps are free tools that you can download to enhance your Origin features, and many of the apps are specific to curve fitting as well. So here is a whole list of apps related to curve fitting that we have published. Okay, so there's a lot more that you can download and add to Origin to enhance your capabilities when it comes to curve fitting. Okay. Also, there is a difference between Origin and Origin Pro. And here is another page on our website that describes the differences. So as you may already know, the Pro version of the product has more advanced analysis features. So this particular page, again, the link is in the project that we will be sharing with you, has a tabulated list of all the things that Pro provides in addition to what Origin software provides. Okay. Again, the apps, many of the apps are only for Origin Professional. So you may want to look at this comparison sheet if you have Origin to decide if you would like to upgrade to Pro, for example. Okay. And let's get started. I'm going to use several examples to walk through various tools and apps in Origin. Okay. So to begin with, let's start with a very simple interactive way of fitting. Okay. So here I have a measurement. Maybe it's like some reaction rate as a function of time. Something happened around time between 4 and 4.5. Perhaps a catalyst was introduced and the rate of the reaction changed. I want to quickly measure the slope in the first phase and in the second phase. So in Origin, depending on what window is active, your menus will change. So here I have graph window active, and you will see there is a gadgets menu. If I make a notes window active, you will see the gadgets menu disappears. So first of all, the menu is sensitive to window type. So when a graph window is active, we have this menu called gadgets. And gadgets are tools that we introduced long before apps were introduced. So there are quite a few tools here. These are all built in. And one of them is quick fit. Okay, to perform quick fitting on the graph to get some quick numbers rather than a very detailed fit with reports and such, which we will see later. So let me choose gadgets, quick fit, linear. Okay. The idea here is that this will then add a region of interest tool. In short, we call this ROI. You can move it around the graph, and the tool is essentially doing linear fit to the data that's covered by that ROI. Okay, so you can dynamically move and resize this rectangle. Okay, plus all of these gadgets have a menu. So if you click on this top right triangle button, you will see various menu options. We'll go through some of them later. Let me go to the bottom menu, which says preferences. That will open a dialog. Here I can make customizations to my gadget. So for example, on top of the ROI box, what should be listed? So here, there is a note here that says currently it's showing parameters, but I also want to show R square. Okay. I can expand the parameter list and I can turn on, turn off things. I'm not really interested in the x-intercept, so I'm turning it off and click OK. So now I see R square value. The benefit of that is I can adjust this rectangle, and if I go too far, the R squared gets worse. So I can back up to sort of decide what's a good cutoff for phase one. So let's say over here looks good. I'm getting a pretty good R squared value close to 1. So I'll call this my first phase. And then let me click this triangle and select new output. So that will put a label on the graph with all of the results from the linear regression, the intercept, the slope, the R squared value, etc. Now I can move it to phase 2. Okay, and then do the same. Click new output. Okay, now I can close my gadget. So just with a couple of clicks in an interactive way, I could analyze my graph and get some results out of it. So I got slope and intercept for the first part and slope and intercept for the second part. Okay. Questions? Feel free to ask in the Q&A or chat window, please. Okay. Let's look at another example. So here I am looking at some exponential decay curves. Okay. And let me again do a linear fit. I'm interested in doing a linear fit to the tail end of these curves. Okay. So I'm going to again go to gadgets, quick fit, and linear. Okay. Note that you can also do non-linear. There are several options. I'm just sticking with linear mainly to give you an idea of the concept of how gadgets can be used to fit. So let me say roughly from time of 0.5 seconds to 1. You can be more precise by going into the preference menu and setting the ROI limits more precisely. Now you can see that Origin recognized one curve and it's showing the fit line on that one. If I click this flyout button, I can change data to the second one. That looks good. I can change the data again to the third one. Okay, that looks good as well. Then I can go into my preference dialog and I can say, where do I want the output to go? That's under the report tab. And instead of sending it to this results log as a text dump, I can say, put it into a worksheet. Okay, then Origin will say, okay, Origin is going to create a book named Quick Fit and a sheet named Result and put it in there. That's fine with me. Click OK. Then over here, now you notice I have new output for all curves or new output for all layers. I can even do this for multiple layers using the same ROI settings applied to every layer. In my case, I have only one layer, so I can choose new output for all curves. Okay, so then an output book is created. I could have turned off these labels if I did not want them to come up. But anyways, here I have a go to report worksheet. That report just happened to be behind my graph. So you can see I have a nice tabulated result here. For DK1, what are my intercepts and slope and error on the intercept? What was the R squared value, Pearson's R, etc. Okay, so this is a nice way of performing interactive fitting on the graph. Questions, comments, please feel free to type them. Okay, let's move on. Let's take it one step further to perform a fit with a more elaborate report. So for that, first I'm going to show you an app. And the name of this app is called Simple Fit. Apps, as I mentioned to you, are free add-ons. Some of them are pre-installed with Origin. Others you can download as and when you need them. The Simple Fit app is pre-installed. If you have any version from recent releases that we had, if you go to the apps bar here, which is docked on the right side, you will see apps in there that are pre-installed. I have many more apps than you may have because I have been testing many apps as they get published. Okay, so you may not see as many as these. So I'll later show you how to manage these apps using different tabs and such. Okay, so here's the Simple Fit app. Okay, so I'm going to launch it. The Simple Fit app requires a graph to be active. I have a graph with some data that I want to fit with linear fit. Okay, let me make this graph a little smaller because that app may overlap graph. Okay, let me click on Simple Fit. Then you can see this nice dialog pops up. It has options for linear, polynomial, and nonlinear fitting. I want a linear fit. You can see that already there's a linear regression curve that has been placed on the graph. And here are the values from the analysis. I can go ahead and add if I want a 95% confidence band. There are other options such as maybe I want to fix the intercept. In this case, it's sensor output versus displacement. So ideally, I want zero output for zero displacement. So I can make adjustments like that in the dialog. And once I'm satisfied, I get a good R squared. I can click report. And then this app will create you a detailed report. Okay. You can see here that the report is one of the sheets that got added to my data sheet. And we call this hierarchical reports. Okay. Somebody is asking about fitting with the power law. That is a bit too specific. If you can contact tech support and send your project and data, we can help you with that. Okay. All right. So this hierarchical report has collapsible tables. So for example, here's a parameter table. Here's a statistics table. Here's an ANOVA table. There are embedded plots in here, including fitted curve plot and residual plots and such. I'll come back to a bit more details of this report sheet with another example a bit later. Okay. Now, let's use that Simple Fit app to perform a nonlinear curve fit. Okay. And in this case, I want to create a new function. I went to Wikipedia and I saw a definition of Gaussian function, which just happens to be this expression. Origin has a variant of this. I want this exact expression with those parameter names. So let me see how to do that using the Simple Fit app. Okay. So with this graph active, I will launch the Simple Fit app again. And this time I'm going to choose nonlinear. And under nonlinear, you can see I can use existing functions as well. If I check it, then There are over 200 or so functions that we ship with Origin for nonlinear curve fitting. They are all categorized. I'll show you examples of this a bit later in the more advanced fitting tool. You could pick one of them if you like, but here my objective is to simply define a new function. So I can come here and paste my expression. The expression needs to be of the form, I remove the y because the yx is outside. So this particular tool only allows simple expressions of the form f of x. Origin fitting can handle a lot more than that, but this particular tool is for simple purposes. So once I put in an expression that doesn't have any parsing errors, Origin will pick up all the parameters that are not x and assume they are fitting parameters. So I have three parameters here, A, B, and C. And this app has arbitrarily assigned value of 1 to each of them. Okay, this app doesn't do any smart analysis of the data to guess the values. Okay, I'll show examples of that later. So I need to look at the graph and say, okay, my parameter here of amplitude probably more like 100. So you can see the curve is changing. B is my centroid parameter. That looks to me more like 25. Okay, so I can put in 25. Okay, the curve shifts to the right. And C is the width, and I can put in something like 5, for example. Okay, so as you change the parameter values, the curve is updating. Then you can go ahead and do one iteration at a time if you wish. Or you can simply click fit, which will run the iterative process till the iteration converges. And then you can see that you get a good adjusted R squared. And then you can hit the report button again, like we did last time, and you will get a report. Okay. Any questions on this tool? The objective here of this tool is to perform quick and simple fits and get a report. Okay. Let's now move on to more rigorous tools in Origin. Okay. So first, let me again come back to linear regression and use the more rigorous linear regression tool built into Origin, and we'll do a few things with it that the previous tools could not handle. Okay. So with the graph active again this time, I have some measurement of absorption, peak absorption value as a function of concentration, say absorption peak area or amplitude, whatever it is, from a spectrometer for a given concentration of a chemical. And I have plotted here known samples. So I used known concentrations, popped them into the spectrometer, did some measurements, and I got this data. Now I want to fit this data with the linear curve. And I also want to be able to predict the concentration of unknown samples. Okay, so let's see how to do that. So let's go to the analysis menu and go to fitting. And here you will see there are quite a few options. There's linear regression, there's fit linear with X errors, polynomial fit, nonlinear curve fit, implicit curve fit, surface fit, simulating curves, and such. Compare data, compare rank models. We'll see some of these later. Some of these menu items may be missing in your Origin if you have standard Origin, because some of these, such as surface fit, are available only in the Pro version of Origin. Okay. All right. So let's go to linear fit and launch the dialog. Okay. Sometimes you may see this last used entry. That is a theme which remembers the parameters that you used last time you used the dialog. The very first time you may not see that. Okay. Anyway, let me open dialog, which will open with all default settings that Origin ships with. Okay. So here is the rigorous linear regression dialog, and this dialog has many tabs. So here it's telling me what's the input data. It's telling me it's coming from graph 3, from the first layer in graph 3, and the first data plot in the layer. I have only one layer and one data plot here anyways. We'll see examples of more complex fitting a bit later. Then I have fit control, where I can again control intercept or slope as such, quantities to compute and such. In many of these tools, our defaults are pretty good for 90% of the cases. So let me just first hit OK and see what happens. Okay. So when I hit OK, Origin does the regression. Then it's asking me, do you want to go look at the report sheet? I can say yes, or I can say yes and do not do the same in the future and don't bother me. So you have dialogues like this pop up once in a while, so you can set a preferable option. I'm just going to leave it as yes and click OK. So what Origin did again is to place a report sheet. And again, this is similar to what the SimpleFit tool did, but there is a significant difference. Here you will see a green lock. Okay. On the graph too, where the curve fitting was done, you will see a green lock. The lock, we call it an operation lock. What an operation lock does is to take an input, put it through a process such as curve fitting, and then create an output and link them all together. So this operation knows what is the input, where did the output go to. Okay. The benefit of this lock is I can click on this lock and I can bring up change parameters. Okay. So I can reopen my dialog the way I left it the last time I did the analysis. Okay. Then I can go here and say, wait a minute, I want a find X, Y option. I want to be able to find X values for known Y values. Remember, I talked about unknown samples. So the idea here is somebody walks up to you with an unknown sample. The sample concentration is not known. You pop it into the spectrometer. You measure the absorbance. You want to know what's the concentration based on this fit curve. Okay, so that's what this find X, Y is for. You can also do find Y from X, which is more trivial case. Okay, so I can say find X from Y, and I can say give me a 95% confidence interval on that calculation as well. And I click OK. Nothing really changed to the fit, but you will see there is a new sheet that was added. It's fit linear find X from Y. Okay, let me move that to the side a bit. So now I can come here and pop in my unknown sample in the spectrometer, and maybe I got a measurement of 0.535. Okay, when I enter that and click out, it immediately shows me an X value. Maybe I get another value, let's say 0.375. I get another X value calculated from that fit. And this sort of find X from Y also works with nonlinear fitting. Then we put in one more value. Okay. Now I can drag and select these two columns. Note that they are in reverse order, Y and X. Typically in Origin, it's X and Y, but this sort of drag and drop still works in recent versions. So you can see here that my unknown samples are now shown by the black dots, and they lie exactly on the fit curve. Okay. Hope this was useful. How to perform a fit, then click to do change parameters and change something, and change some of the settings or add more options. We'll see more of this as we go along. Okay. Let's move on to some examples of nonlinear fitting. Okay. Let me go through some multiple data set examples. Okay. So I'll show you now how to fit data, whether you start from a graph or you start from a workbook. And there are subtle differences to the two. Okay. Typically, most users make a graph to look at the data and then fit. So let me first show that. So here I have some decay measurement, 3 different experiments, decay 1, 2, and 3, and I want to fit them with some exponential function. So with the graph active again, I'm going to the rigorous tool under analysis, fitting, nonlinear curve fit, and open dialog. Note that this is a shortcut. Nonlinear curve fit is the most commonly used tool in Origin. So we have a shortcut Control Y. Next time I'll just use Control Y to open it. Okay. So once I do that, the nonlinear fit tool opens. If you have never used this tool, it might be a bit intimidating at the beginning. There are lots of controls and tabs, but we have excellent videos and documentation on this tool that you may want to look up first. So first of all, there are some tabs here. The first tab is Settings tab. In the Settings tab, we do basic things like setting which function you want to use, deciding what data you want to fit, etc. You may never need to go into the code tab. This is things like any script you need to run before fitting, script after fitting. constraints which you may or may not want to apply. For these, I would recommend that you watch the more advanced curve fitting webinar that I referred to, the recording of which is available from our website. Okay, I'm not going to go into constraints and bounds, etc. in today's webinar. Okay, so under settings tab, the first thing to do is set a function. You have a category here. Okay, our functions are all set in categories. So for example, I can choose exponential category and I can choose a function from the drop down. Now it's showing me all the functions available in the exponential category. I can choose exponential decay 1, for example, or I can even click the search button and type something here. Okay, so for example, I can type decay, and then it will show me all the functions available for decay. Okay, and it's showing me the expressions as well. So if I really want a different function, I can pick from here as well. Okay, if you want, for example, the exponential decay with offset, you just double click. Okay, and that function gets chosen. Okay, so it's very flexible how you choose functions. Let me go back to XDEC1. Down here in this panel, you will see formula, which shows you clearly what the formula of the equation is. You will see a sample curve, which gives you an idea of what the parameters mean. There is a messages tab, which is saying, okay, parameter initialization was called for this function. And when you look at the graph, you will see, as we saw earlier with that gadget tool, is that Origin only recognizes one curve, because Origin has this concept of active graph, active layer and active data plot in a graph. So if a graph has multiple layers and each layer has multiple plots, it will pick up the first plot in the active layer. So that's what's showing me here. But I can fix that by going to the data selection. Okay, and under data selection, you will see this input branch. You will see there is only one range. Range is just another reference to the data that's being fit. Okay, so in the input data branch here, towards the right side, I can click this little button and I can say add all plots in active layer. I can even add all plots in active page if I have multiple layers. So if I click this, you will see it added range 2 and range 3. Okay, the benefit of that is you can see the curves right there. Okay, it put some estimate curves on the second and the third. Now I can do fitting, fit one iteration or fit until converge. It is still fitting only one curve, but I can switch to curve 2 and fit that. Okay, and I can switch to curve 3 and fit that. This way I can play around with my data to make sure my function selection seems good for most of my curves. And then I can click OK, and it will generate me again a detailed report. Okay, so if I go here, in this case with multiple data sets, there is a parameter table, but perhaps most useful is a summary table, which shows the same information in a transform way. Okay, so here I have all my values. Okay, this particular summary table, any table in this report sheet, by the way, you can click and you can say, you can copy it as HTML, so you can paste it into your Word document or any other HTML accepted, any other lab notes software that accepts HTML for pasting in. You can also just copy it as plain text. You can create copy as a new sheet. It will create a new sheet. And when it creates a new sheet, it's not copying the literal values. It's actually linking back to the report. So if the report changes, this sheet will also change. So from here, you could plot this data and do subsequent post analysis of your fit results from multiple curves, for example. Okay, many features in this particular sheet, what we call the report sheet or the hierarchical sheet. Okay, right? Okay, now let's go back. How do we fit from a worksheet rather than fit from a graph? So when you fit from a worksheet, you have the benefit of selecting your columns. Okay, so for example, I can drag and select these 3 columns. Okay, so I have pre-selected my data. Now, if I go to analysis and go to fitting and go to nonlinear curve fitting and bring up the dialog, what I wanted to show you is if I go to data selection and expand this input branch, all the ranges will be pre-populated because Origin knows you had selected 3 columns in the sheet, so it automatically picked them up. Then you can set your function and perform the same fitting that I did before. Just wanted to show you the difference that when you fit from the worksheet, you could even do things such as drag and select a particular range. Then it will fit only that sub range of the data. Okay, we'll see more of that soon. Questions? I see some activity in the chat window. I don't see anything in the Q&A window. Feel free to ask in either window. Thanks to my colleagues for answering the chats that popped up there. Okay, let's move on to another example, replicate fitting. So in pharmacology in particular, you may perform multiple measurements on the same experimental setup. So here I have like a response versus dose for 3 different measurements. And when you fit such data, you do not want to fit them separately. You want to rather combine all the data sets together and fit. There are 2 ways to do that. One is you could go here, you could select all the columns, you could go to the statistics menu and do descriptive stats and stats on rows, and then you can compute a mean and standard deviation and then fit that reduced data. But rather than do that, which may be in some ways biased, you could fit the raw data itself in Origin. So let me start from the graph and show you how. So if I do Control Y to bring up the dialog, and now in this case, I'm going to choose the growth sigmoidal category. And specifically under this category, I'm going to choose the dose response function. And the formula for that function is here, the standard dose response function. And if I go to data selection again and looking at the graph, you will see there's only one curve. So I can expand this input again, and I can say, pick up all the curves from my graph. Okay. Sorry, I have to click on the top level at the input level. And I say add all plots in the active layer. Then I get all 3 ranges. So you will see there are 3 curves, but that's not what I wanted. I still wanted 1 curve. That's where this control comes in, multi-data fit mode. This can be used to either independently fit 1 curve at a time, which is what we did in the previous exponential decay example. That's the default. But this can be changed to do concatenate fit. Perhaps we should have called it replicate fit, which would be a better name, or can be used for a global fit. I'll show you global fit next. Let's choose concatenate fit. Then what happens is Origin treats all of the data by combining it all together into internally 1 data set. And it's fitting that, and it's showing me only 1 curve. Then in the fitted curves section, I can change plot type from raw data to mean and standard deviation, or mean or standard error, whichever is your choice. Then you can say, see that it's internally reducing my data to mean plus standard deviation, even though the fit is actually done on the raw data. So then I can go ahead and perform the fit, click OK, and I'll get my report. On my graph, of course, I had plotted the raw data, so it'll look as if it's just the raw data. But if I go to my report sheet, you can see the embedded fitted curve here is actually showing me the mean and standard deviation. Okay. Okay. Let's look at a global fitting example. So here I have 4 peaks, and I want to fit them by sharing some parameters. Okay. So this is an embedded graph, by the way. You can take a graph and leave it as floating on an Origin worksheet. We have tutorials on this, how to work with graphs and worksheets and such. Many hundreds of tutorials on YouTube, also on our website. At the end, I'll show you our support page. Please remind me. Let me just double click to pop up this graph. And what I wish to do here is to fit all these 4 curves, but I want to share some parameters, such as say, force all the widths to be the same, which would be a global fit. Okay. So with this graph active, let me hit Control Y to bring up the nonlinear fitter. I'm going to choose a peak function. So I'm going to go to my peak functions category, and I'm going to choose Gaussian amplitude function. And here's the formula, how it's defined. Then if I go to the data selection again, from a graph, as you know, it'll pick up only one curve. And this time it's picking up the curve from whatever was the active layer. My third layer happened to be the active layer when I launched the dialog. So now I can go to my data selection and click here, and then I can say add all plots in active page. So now it's going to go across all layers and pick all of them up. So now you see it's picking up from layer 1, layer 2, layer 3, layer 4. Okay. Now I have all of the input data specified. Okay. Now if I go to parameters, you can see that there is a y0 xc wa for curve 1, y0 underscore 2, xc underscore 2, w2, a2 for 3, for 2, 3, and 4. Okay, so there are 4 sets of parameters. We come back to settings, and under the multi-mode data that we saw, fit mode that we saw earlier, there is a global fit option. If I choose that option and go back to parameters, a new control appears called share. So now I can, let me show you clearly what happens. I can collapse this bottom panel. I can make this panel taller. You can see now there are multiple width parameters, but what happens when I share it? When I share, all the other widths disappear. So I have only one width parameter. So that means I'm asking Origin to fit all 4 curves simultaneously and forcing the width to be the same. Whatever value of the width parameter will best fit all 4. Okay, so then I can click my iterate button if I wish to. Okay, and see how the fit looks, and then click OK to generate my report. So let's go take a look at the report. So in the report sheet, you will see that in the parameters table, the W has the same value. Okay, easier to see in the summary sheet. You can see here the Y0 values are different, the XC values are different, the W values are all the same, and A values are different. This is because we only force W to be globally shared. Okay, hope this is useful. We also have an app for fitting multiple data sets with different functions and share the parameters across, even parameters with different names. Okay. All right, let's move on to another example of specifying X range for fitting from a graph. Okay. Remember earlier I mentioned I can go to a worksheet and drag and select a certain subrange and fit that subrange. What if you're working with a graph? How would you do that? Okay, so here I have a graph, and I just want to fit the tail end of this graph with a single term exponential decay. I know that maybe this graph is data is best fit with the 2-term exponential decay, but I'm interested only from say 0.4 onwards to 1.0 in time. So with the graph active, if I go to the left of the interface, there is a tools toolbar. This tools toolbar has various tools that are pertinent to working with graphs. One of them here is selection tool. Okay, if you click on it, there's a selection on active plot or a selection on all plots. So I am going to choose all plots. And then if I walk over to the graph, it shows me a cursor. I can even hit the space key to draw either a rectangle shape or an arbitrary shape if I want to. I'll just choose a rectangular shape, and I'm going to just roughly drag and draw a rectangle. So Origin essentially defined the range for each of these curves to be roughly around from 0.4 to 1. Okay. Now let's hit Control Y to bring up the dialog. Okay. So now let me go to the exponential category. And I'm going to choose a simple one-term exponential decay function. Okay. Once I choose that, let me go to the data selection. And let me show you here what happened, how that selection was taken into account. So if I open the range, open each of these, you can see that the Y node has a by row condition. It's saying only from rows 41 to 100, okay, which happen to be the row numbers for my data, roughly from 0.4 to 1.0. But I may not want to go by row because my data sets may be X, Y, X, Y, X, Y, and they may have different spacings. I can change it to by X. And I can say precisely, for example, say I wanted to fit from 0.45 onto 1, for example. And if I do that, I can even click here on this range and say apply the row range to all. So it will take the row range settings of range 1 and apply to range 2, range 3, range 4, as many ranges that you have. Then if I expand them, you will see they will all consistently show a by X range of 0.45 to 1. Then I can perform my fit and click OK. And only that particular X range of the data will be fit, as you can see from the graph. Okay. So this gives you flexibility even in working with the advanced tool to perform curve fitting over a specific range. If I'm going too fast, please ask me to slow down. I can cut down on the amount of material that I'm covering. I see I have another maybe 15 minutes. Okay. Okay. Let's look at a couple of examples of fitting with error bars. Okay. So here I have a peak data with some measurement error. So if my worksheet happen to have X, Y, and Y error, as you know, in Origin, you can set columns to be of different types, X, Y, Y error, etc. If I bring up the curve fitter from this graph and I choose a function, let's just stay with basic functions and choose the Gauss function. If I go to data selection, and if I expand the input and keep expanding and drill down to Y, you will see for the Y, Origin automatically picked up a weighting method. So because a Y error column was already plotted, it's assuming it's instrumental error, which would be 1 over square of whatever that value was. That's Origin's default. But note that I can click here and I can change it to many different weighting methods. There are like 10 different methods. Whatever is recommended in your field of work, you can implement that. Okay, so I can click fit and then the fitting will be done, including the weighting. So if I go to the notes here, it will clearly show that, let me see, is it the notes or maybe it's the input data. So the input data will show me details of weighting, and X has no weighting, Y has instrumental weighting. Okay. Let's look at an example of X and Y error. Okay. So in old versions of Origin, we had only one algorithm for iterative nonlinear curve fitting called Liebenberg-Marquardt algorithm. Okay. In the recent versions of Origin, actually many versions ago, we introduced this. In Origin Pro, we have an additional method called orthogonal distance regression. So as you may already know, Liebenberg-Marquardt only minimizes the difference between the square of the difference between the data point and the fit curves. It's only looking at Y errors. It cannot look at X errors. Orthogonal distance regression is actually minimizing the square of the distance from the data point dropped perpendicular to the fit line. In this case, I'm showing a linear example, but with nonlinear, it's the same. Okay. So let's, with this data set, which has both X and Y errors, because the worksheet was set up, one column was set up with X error. Let me bring up the fitter. Okay. Just wanted to show you that this possibility exists. I can go pick a function here from the exponential category, for instance. Let me pick the one-term exponential decay. And you will see down here, there is an iteration algorithm. I can change it from number marker to orthogonal distance and then perform the fit. And in this case, the fit will take into account both X and Y errors in your data. Okay. All right. So let's take another look at some of the curve fitting apps. Okay. First, I wanted to show you the App Center again and show you how to download an app. You may or may not have used apps. So if you go to the App Center, by the way, these dialogues, you can drag them out. You can dock them back to whichever side of the interface that you prefer. You can pin them down, or you can auto hide them, your choice. Okay. In here, the very first button here is Add Apps. So if I click on that, it opens what we call the App Center dialog. Okay. In the App Center dialog, I can go search what apps are available from the website to download. Okay. My search is a bit slow. Let me see. Does it catch up? Okay. So here I can go even type keywords. For example, I can type fitting and click search. Then it will show me all the curve fitting apps that are available. So there are many: neural network fitting, peak deconvolution, speedy fit, fitting function library, compare data sets, etc. If I see a fit tool that I like, for example, fit composite functions, I simply click this download and install button. And that will go get the app from the website, install for you. Note that each app has a minimum version requirement. So this requires you at least have Origin Pro 2019. As I mentioned before, some apps only work with Pro, some work with standard as well. So once you download, you will see a green check mark. Then if you close, you can see here in the App Center, I can right click in the white area and sort the apps either by alphabetic order, newest installed, or recently used. So if I choose newest installed, there it is. Fit with composite functions I had just downloaded. So that bubbles up to the top. Sometimes the App Center doesn't work if you have a firewall. If that's the case, you can go to our website, go to communities, user file exchange, and all the apps are here. You can again do search such as fitting and search and find an app. Then you can simply click on the page of that particular app, for example, compare data sets, and then you simply download the file. And once the file is downloaded, it'll ask you to log in. You can then drag and drop the file on top of Origin to install. Just wanted to let you know, sometimes a company or even a university might have a firewall that blocks talking to our website from inside of Origin. So you will need to go to the file exchange page to get the app. Okay. That's about downloading. Let me then show you a few of these apps. So one of the apps I wanted to show you was the fitting function library. I have it already installed, so let me simply open it. Okay, so this tool, what it does is we have been adding fitting functions to Origin for years and years. So recently we decided, why add functions that not everybody may need? So we have started putting up functions on our website. And this tool lets you view all the functions that are available on the website. You pick and choose the ones that you want. Okay, so here are a whole bunch of functions on rheology. Here's some on enzyme kinematics. Okay, here's some peak function, a Lorentz amp function. You click on it, it will show you the particular expression and a simple curve sample, etc. You pick the one you want, and you simply go to this download button and download it. Okay, you can even uncheck this, so it will go into the peak fitting and peak functions category instead of the user-defined category, and click download, and then it will show a green button, which means this is now part of your collection. So then you can go to your nonlinear fitter and start using it. The idea here is, if there is a function that's popular in your field and you would want to see it in Origin, please reach out to us. You can click this request a function button, and that will take you to a ticket system on our website, and you can put in a ticket saying, hey, I would like this function added. We can optimize the function and put it up, and then you can simply use this app to download it. Two benefits to that: it helps you Plus, it also helps the community of users. They will be able to see the function as well. Okay. So we would love to hear from you about that. Okay. Let me show a couple of other examples just to give you a flavor of why these apps are useful. So here I have a data set here. Or rather, I have a worksheet with 96 XY data sets and 96 well plate measurement. Okay, if you are familiar with pharma measurements. So I want to fit all of them, and I don't want an elaborate report like that hierarchical report. I want a quick fit and a simple table. So let me go make this book active, and then I'm going to launch this app, SpeedyFit. Again, it's a free app that you can download. So the app comes up. It can fit linear, polynomial, or nonlinear. I'm going to choose nonlinear. Here again, I can choose a category. I'm going to choose exponential category. And asymptotic function fits my purpose well. So I'll stay with that function. You can see here it's showing the first data set. I can go ahead and click fit. That looks good. Can go to the next data, click fit. That did not work out well, but then some of the wells in a well plate can be bad. I can click next and fit. Everything looks good with that. I can go to report settings. I can turn on and off any number of options here for my report. Can go back. I can click OK. Then what Origin is going to do is just churn through all 96 very quick. And this is much faster than using the nonlinear fitting tool. This was done specifically to perform the fit and give you a quick table. Now, here's my table. Let me hide this app window. Here's my table. Let me stretch this a bit. You can see that here are all the values, standard error, adjusted R squared, and there is even a particular column here saying did the fit succeed or not. Okay, there's a message here. Okay, you can see some of them did not succeed. The beautiful thing about this app is it also places an embedded graph here. Okay, SpeedyFit all data, SpeedyFit curve. Here's my curve. Double click to pop up this graph. Let me make this graph a little smaller. Okay. And I'm gonna move this label to the side. These labels can be customized. I would recommend that you go look at some of the webinars where we went into more details of curve fitting and customization. So here the nice thing is I can flip through and look at all my data. There was a second one that failed, remember? Here's the third one, here's the fourth one, here's the fifth one. I can explore how the fitting worked graphically after that quick fitting was done on all 96 of my data sets. Okay, so hopefully that's a useful tool for you if you work with many data and you want a quick report and an interactive graph to look at the results. Okay, last, I want to show you a rank models app. Okay, before I show you, we often get this question, how do I decide if my function is best, which is the best function for my data? That's a tricky question in the sense there is no good statistical answer to that question. It really depends on what model is typically used for that data in your field. A better question to ask is if I have one data set and two or more functions, how can Origin help me decide which function is best? That's a more appropriate question. And for that, there is clearly a good statistical way of deciding that. So here what I did is I took some exponential data. I fitted with a single term exponent function. Then I fitted with a double exponent. Okay. And you can see that with the double exponent, the R squared is better. So obviously, as you add more and more parameters, the fitting function can wiggle more and more, so it can follow the data points closer. So then the question here is, do I keep adding more and more terms? When do I stop? So the answer to that is you can do a statistical test to determine what's the best model. So for that, we have this particular app. So by the way, for the data, here I can select the data and go to my analysis menu, go to fitting, and there is a rank model dialog, which is an older dialog. I would recommend that you use the rank models app that we created. If you have many apps, by the way, and if you want to find one quickly, we have this feature called Start Menu. You may or may not have noticed on the bottom left of Origin, there is a Start Menu button. You can click on that, and under Find, we have videos on this. You can go look. I can type A for app, and type rank. Immediately it will show me there's a Rank Models app installed. Then I can just click on that and it will launch the app. So I don't have to go hunting in the app bar. Okay, quick and easy way to launch the app. So under this tool, it picked up my data already. Now my job is to pick functions. So let me pick the exponential category. Okay, I'm going to choose, for example, a single term exponential decay, 2-term exponential decay, 3-term exponential decay, and I'm going to choose the same with an offset. So that's a more complex function. Then I'm going to say fit all of these and report to me adjusted R squared and fitting outcome. So what I'm doing here is I'm asking Origin to take one data set and fit it with a host of functions and somehow tell me statistically which is the best fit. And what is that statistical measure? There are two. One is called AIC, Akaike Information Criterion. The other is called BIC, Bayesian Information Criterion. You can Google and read Wikipedia about it. Many products offer this nowadays. It's not something we invented. It's a standard calculation that uses degrees of freedom and sum of squares, etc. The idea here is that if you compare a bunch of fits, the fit with the lowest AIC, BIC is the one that's the best. You don't need to look at both. BIC is more recent version of this information criterion. So here I'm going to just focus on BIC. You can see here Origin already put XDEC2, which is a 2-term exponential decay, as the best function. The next function is XDK2, which also involves an offset parameter. So it's saying you don't really need an offset. Obviously, in my case, I don't need an offset because my X values start from 0. So the second term exponential decay happens to be better. Is a third term exponential decay needed? No, because that will be an overkill because the 2-term exponential decay already gave me the lowest BIC. So again, this valid statistical question is given one data set and n models, which is the best model. Okay, hopefully this was helpful for you. That covers pretty much everything I plan to talk about in this webinar. Let me bring up the website and again show you where you can find the recordings. So go to support. And let me actually show you under support the Help Center page. So if I choose Help Center, it brings you to the main support page, which has many resources, video tutorial link to our technical blogs, FAQs, user forums, apps, graph gallery, case studies, and webinars. Over here, you can schedule a call or you can submit a support ticket where you can even attach your files and ask your questions and we will reply to you. Okay. There are other things here like renewing your maintenance and such. If I click on webinars, it'll take you to the page that I showed before, upcoming webinars, and also all the recordings. So today's webinar, the recording and the project file will be available to you early next week. Okay. Hope this was useful to you. If you have suggestions for other areas where you would like to see webinars, you can put them now in the chat window and we can consider those. Thank you for attending and you have a wonderful weekend and stay healthy. Thank you. I'll leave the chat window and QA window open so you can keep typing. We will record all those and we can look at your comments for future suggestions. Thank you.